3D printers have been around for quite a while now, and especially the FDM 3D printers are relatively cheap to purchase. Now, all of my 3D printers are FDM 3D printers, and they work by using a really hot nozzle to extrude melted plastic, similar to a hot glue gun, which will build up many layers until eventually you have a 3D printed component. Now, you may have seen online people 3D printing radio-controlled model aircraft, and I in fact designed and 3D printed my own model aircraft about 2 years ago in 2016. But things have changed quite a bit since then, and what I'm going to do today is show you how you can design and 3D print your own lightweight components for model aircraft or any other application. So let's jump into Fusion 360, which is the CAD program I'm currently using. And let's make a sketch of a cylinder. So I'm going to make it 100 millimeters in diameter, and then let's make a wall thickness of 0.4 millimeters. So 0.4 millimeters is the diameter of my 3D printer nozzle, and will most probably be the diameter of your nozzle as well. It's like the standard size nozzle for 3D printers nowadays. And you can probably use a smaller 3D printer nozzle to print really thin, lightweight parts. However, I'm going to show you how you can configure your slicer software to work regardless of the diameter of your nozzle. So if I just extrude out this disc to 100 millimeters in length. So we now have a cylinder which is 100 millimeters in diameter, 100 millimeters in length, and 0.4 millimeter wall thickness. So if I just apply, I'm going to apply a material to it. I'm going to say it's ABS plastic, which is slightly lighter than PLA plastic, but just to get a rough idea. So Fusion 360 estimates this will weigh 13.3 grams, let's say. Now let's export this as an STL file and import it into Simplify 3D. Now Simplify 3D is the slicer software I use. Just a disclaimer, I'm endorsing it as a customer. I'm not affiliated with them. They didn't send me the software or anything. I purchased it with my own money. And I just like using it. So this is the slicer that I'm using. Now if I click prepare to print, we should see a bit of an issue show up. Now this shows up because the the slicer software won't allow the printer to print anything thinner than 0.4 millimeters. And when it curves at an angle, some of the parts to the slicer look like it's less than 0.4 millimeters, and it just doesn't detect it. So the only way to get around this, or at least one way to get around it, is to increase the wall thickness to double the nozzle diameter. So now we have a part which theoretically will weigh twice as much. So if I import that into Simplify 3D and then click prepare to print, we now have a proper cylinder. As you can see, the part has an outer wall, well, it has two outer walls technically, but it has the outer disc or outer cylinder and then the inner cylinder, and the total weight is 34.4 grams roughly. And yeah, that's double the amount of weight that we want it to be. Fusion 360 estimated 13 grams. So yeah, pretty much double, if not a bit more. So back in 2016, when I designed my original 3D printed planes, I will show you exactly how I got around this issue. What I would do is I would extrude the part as a solid. So now the cylinder, it's not hollow down the center, it's like a rod, not a tube. So if I export that as an STL, then import into Simplify 3D, we now have the solid cylinder, and to get this as a single wall single outer wall thickness hollow cylinder, what I'd have to do is put the infill percentage to 0 and then remove the top and bottom layers, and the outer layer is one wall, and there we have it. We have a cylinder which is hollow down the center and now weighs 17.3 grams, so slightly heavier than Fusion estimated, but PLA is slightly more dense. So now we have that successful cylinder, a nice lightweight cylinder. The problem arises now is how do we design something inside the cylinder? For example, if we want to add a reinforcing rib or a mount for some kind of electronics, we have a bit of an issue because in the slicer software it looks like this, but in the CAD software it looks like this. And I don't know about you, but I can't seem to work out how to design a solid inside of a solid. I don't think physics quite works like that. Now, I'll post a link to the video that I did back in 2016 of how I designed my plane. It was done through quite complex trickery of configuring the CAD program to work with the slicer software, or at least confuse the slicer software to build certain solids. But nowadays it's a lot easier because Simplify 3D has a new function built into it, or at least it's new to me. I've only just come across it this week. So let's go back to the cylinder when it was 0.4 millimeters, 0.4 millimeter wall thickness. So there we have the original cylinder from the first model. And what I'm going to do is I'm going to import this back into Simplify 3D. And then if we go into the edit process settings, which is down in the corner, which is where you adjust all of your 3D printer settings. I don't know whether this is available in any other slicer. I only have Simplify 3D and I've only really ever used Simplify 3D. So it might be available in, for example, Cura or any other slicer, but I'm not entirely sure on that. But if we go into the settings and click on the Advanced tab and look down to the Thin Wall Behavior box, there is a drop-down box thing menu here, and it's default as perimeters only. But if we do allow single extrusion walls, and then the allowed perimeter overlap, I've set it to 50%. I think the default is 15 to 20%. I think basically what that is say if you have a wall and then another wall joined at some sort of angle, it's the overlap that they join together. So I just set it as 50% just as a guess, and it seems to work fine with some of the prints I've done. So just changing these two settings, click OK, and then prepare to print. And now we have a single wall thickness cylinder. And to prove it's single wall as well, you can see 17.3 grams. So now we have the cylinder showing up as a hollow cylinder in the slicer, as well as being hollow in the CAD program. So now we can design whatever we want inside of the cylinder, and the slicer should be able to pick it up. Now there's a few other things that I want to go through, and the next thing is how to design a reinforcing rib into this cylinder. Now let's just draw a sketch on this plane, and if I draw a rectangle through this, I'm going to rush through this because I don't really need to constrain everything just for this example. But that's a 0.4 millimeter thick plate that will go through the cylinder. So let's extrude this all the way through. It's currently set to a cut, so let's set it to a join. And then, nope, make it symmetrical. So now we have a solid plate throughout this cylinder. Now to make it just as like a reinforcing ring, what you can do, it's a bit of a cheat in Fusion 360 which I've come across, and you can simply highlight each side of this plate, the external sides. I don't highlight the inside because then it will delete the whole disk inside, and then simply click delete on your keyboard. Now this does run into some issues if you try to design some really complicated shapes. For example, if I designed many different ribs like this and deleted the external faces every time I did one, if I went back and modified the first rib, it then has to recalculate everything you've deleted from then onwards, and it can cause Fusion 360 to crash sometimes. So just be aware of that when you design these parts. You can't go too complicated when you're deleting all these things, because it is a bit of a cheat in Fusion 360, but you can get away with it for some various designs. So now if you want to hollow out this thing, you can draw a sketch onto this plate, and what I do is I just do an offset it by 2mm. And now let's cut that out. So now we have a nice ring inside of our cylinder, which once printed out should prevent the tube from losing its circular shape, you know, like with a toilet roll, you can squeeze it. Whereas with this ring, it will add some reinforcement. So if I export that as an STL and import it into Simplify 3D, click Prepare to Print. So there we have it, the lightweight single wall thickness cylinder with a reinforcing rib on it. Now the only issue with this is that you still have to take into consideration that 3D printers can't print in midair. There's a limit to the overhang that you can have on a part. So for example, if I try and show you this ring round here is printed with no support. Now you could add support to this, but I don't recommend that you do that, because if you had multiple rings up the length of this cylinder, there's no way you could add support to all of them without laying support on top of the previous ring. So what I like to do is just, if I just click undo till I go back to the sketch, get rid of the constraints, and then I like to just angle it. So I like to make all of the reinforcement ribs at about 45 degrees to the horizontal, and that way we don't get those overhangs. So I just quickly model this. Extrude out the other side, and then it's exactly the same process. Delete both sides of the plate, and then draw a sketch on one of the faces of the disc. Do an offset of 2mm, and then cut this. So now we have a diagonal ring, if you can see that. And now if I export that and import that into Simplify 3D, we will have a 3D printed lightweight tube with a reinforcement diagonal ring inside it. And there we go. You can have that fully 3D printed and only weigh 17.74 grams. So pretty lightweight. Now you can obviously add whatever customized ribs that you want and go to all sorts of extents to make this cylinder stronger, weaker, lighter, heavier. 3D print any kind of mounts inside where you want to mount an electronic servo for controlling something. But if I just open up this model, I'll show you what this is capable of doing. This is a design I've been working on for a future plane which will be coming out soon. I'm going to be making the STL files for this all up on Thingiverse. I'll be putting the CAD files up as well. And as you can see here, this is the fuselage for it. It's all single wall thickness designed, apart from this rear section, because what eventually it's going to have is a tail spire out the rear here. So I just made this back part solid so that it's strong for this 3D printed, or sorry, for this rear spar. But as you can see here, the ribs which run horizontally along this fuselage, because what I'm going to do is split it in half and 3D print each section vertically, so these ribs will actually be vertical when I print it. But I use exactly the same technique. I draw a plate at a horizontal axis right there, extrude out either side, delete the top and bottom of each external part of the plate, and then just cut out the inner part using the offset tool. And same with these reinforcement plates for this part here. I simply drew a plate, threw it diagonally from the top, looking from the top, and then deleted the sides off. And yeah, you can design pretty complex, intricate designs. So what I'm going to do now is put this into Simplify 3D, export the G-code, stick it in my 3D printer, and I'll probably put up the 3D printer settings on the screen whilst it's 3D printing. And yeah, I'll be back in a few hours. Probably quite a few. I think it estimates about 10 hours for this print, because you need to print these stuff quite slow. See you in a bit. So the 3D printed fuselage parts have finished, and they've turned out really nice. I did have a few issues with the printing at first. This was my first attempt at the rear section of the fuselage. One of the layers did split slightly, and I think this was due to slightly incorrect printer settings. I printed it slightly too fast and also not enough extrusion. So what you want is to print it really slow and extrude slightly more plastic than you usually would for printing regular solid items, so that it really pushes the layer and melts it into the layer below. So for example, on this skin, I can't push my finger through that. If that was if I printed that at a much lower temperature and a lot faster, I'd be able to push my finger through that. The layer strength is really strong on this part. Now I recommend you use high quality plastic. I like using PLA just because it's got really good layer adhesion. I've tried it with ABS before, but I couldn't get the same layer strength. I'm using PLA plastic from my 3D printer sponsor, 3D Prints UK. They provide really good 3D printer filament. I'll link them in the description below. But yeah, it's really important that you have high quality filament, because if it's not a constant diameter filament all the way along, you'll get weird bumps in the finish, and it just doesn't turn out too nice. Now there is a bit of stringing inside here. That's just because I had to turn the extrusion up a little bit, but with a heat gun it will just melt away really easily. So what I'm going to do is I'm going to glue the two halves together, and then we should have a functional fuselage for a plane. Now I'm going to use CA glue, super glue. This is from another YouTuber called RamiRC. You may have watched his videos before. He sent me this, and he's just reached 100,000 subscribers, so congratulations Rami on that. So thank you for sending me all this glue. Now this is the tricky part, trying to align it. Yeah, I probably need to practice on my gluing of these parts. But there we have it, 3D printed fuselage for an aircraft. Put the lid back on the glue. Right, so now you're probably thinking, right, how much does this fuselage weigh? Well, let's stick it on the scales. And if it's not going to balance. So 58.8 grams, so yeah, about 59 grams, which is not bad for a fuselage of this size and the sorts of aircraft that it will be put on. Now, it's slightly heavier obviously than if you were to make it out of foam board or balsa wood, and in fact I've got one of my old radio control planes right here, which uses a foam board fuselage, but quite honestly with my radio control planes, the worst part of the build always seems to be the fuselage. I don't enjoy building the fuselage. It's always awkward to try and make it relatively aerodynamic and also try and fit all the components inside of it. And also in a crash, the fuselage is always the first thing to be destroyed because it's the first thing that hits the floor usually. Whereas with this 3D printed fuselage, yeah, I'm sure in a crash it will probably obliterate itself as well. But because it doesn't require any man hours, of work, I can literally just click it on print, and a day later I'll have a brand new fuselage. As well as it being very aerodynamic with the design in terms of the airflow. It's also got servo mounts built inside, which will control the rear elevator and rudder through the tube. So it just allows a few more design features to be added. Now I haven't done a tutorial like this before, so I hope you guys enjoyed it and found it interesting. I hope this intrigued some of you to go out and design your own fuselages. As I mentioned earlier in the video, I will be publishing the STL files to this fuselage on Thingiverse. I will also be posting the CAD files. I think I can post Fusion 360 CAD files, as well as the STEP files, so that you guys can edit the fuselage yourself if you want to modify it for a motor mount on the front, for like a puller propeller. Then you can do whatever you want to this fuselage design. If you enjoyed this video, please leave a thumbs up. If you're new to my channel, please click subscribe. A huge thanks to all of my patrons for supporting me. You guys make these videos possible, and if you appreciate my work with this 3D printed design and this tutorial, it'd be greatly appreciated if you could support me on Patreon, because that helps me make all these projects and videos. Now, some of you, smart-eyed people will probably have noticed what this project is for. There are a few clues in this video, and yeah, I'm sure you'll probably comment it in the description, in the comment section below. But basically, I'm working on a new plane, and this is the first part to it. I will be uploading all the 3D printer files for this new plane onto Thingiverse, and I will probably be making a tutorial series for my Patreon supporters. So, thanks once again for watching, and I'll see you in the next video. Goodbye.